2.4e, adding with a different denominator. When we add fractions, we need a common denominator. So the last 3 or 4 lectures leading up to this have been about all about getting to the point where we can add fractions with a different denominator now. Because what we have to end up doing is turning this problem, adding with different denominators, into a problem we already know how to solve, adding with the same denominator. So how do we do this? To add fractions with a different denominator, we first find the LCM of the denominators. We then make equivalent fractions with LCM as denominators. So we multiply top and bottom by the same number so that the denominators end up being the LCM. Then we can add the fractions together. So let's go through an example. This may seem a little abstract at first, but I think it'll make sense through the example. So we have 3 over 2 plus 1 over 3. So we first find the LCM of the denominators. So the LCM of 2 and 3. Well, we can just do mental math and see that the least common multiple of these two numbers is going to be 6. Right? Because if we listed out the multiples, we would circle the smallest one. The LCM of 2 and 3 is just 6. So what we have to do now is multiply both of these fractions, top and bottom by the same number, to make equivalent fractions with a denominator of 6. So how do we multiply 3 over 2 and turn it into something over 6? Well, we can see that if I multiply the 2 by 3, that would become a 6, and I have to multiply top by the same thing, so this would be 9 over 6. 9 over 6 is equivalent to 3 over 2. Now let's do it with 1/3. I multiply top and bottom by something to get it to be something over 6. Well, if I multiply the bottom by 2, it turns a 3 into a 6, so I have to multiply top by 2, because you have to multiply top and bottom by the same thing. So this would be 2 over 6. 2 over 6 is equivalent to 1 over 3. Now I can add like normal. 9 over 6 plus 2 over 6. This is just, we keep the denominator the same and add the numerators. 11 over 6. And that's our answer. Our answer is 11 over 6. If we were to look at this pictorially, it would be a little different. So let's look at some bars. So if we represent 3 over 2 with bars, we would have 2 bars, right? One half full and one totally full, but cut into sections of 2. Now let's look at 1 over 3. We would have 1 bar cut into sections of 3 with one of them shaded in. If I wanted to add these, what I ended up doing was cutting them all into sections of 6. So I ended up with 2 over 6. I have 1, 2, 3, 4, 5, 6 pieces now. And if I cut these into groups of 6, so I cut down the middle here, and I cut down the middle here, and I cut down the middle of another one again. So say I did this, boom, 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 boom. So now they're in groups of 6, right? If I look at this, this is 6 over 6, this is 3 over 6, and this is 2 over 6. Adding these all together, I get 11 over 6, which I have here. So what we really did, what this picture really helps with, is showing that we need to have our things cut up into equal portions to be able to add them. So that's why the denominators have to be the same. Let's look at another example. The specifications of a job require a cut of 2/3 inches, but your boss tells you to add another 1/6 inches to the cut just to be safe. How much are you cutting now in total? So we have 2/3 plus 1/6. We have to first find the LCM of 3 and 6. Well, this is pretty clearly just 6, right? Because 6 is a multiple of 6, and so is 3, and it's the smallest. So the LCM of 3 and 6 is 6. So we don't have to do anything to this fraction on the right here, because the LCM is already the denominator. But what do we have to do to get the denominator to equal 6 over here? 2/3. We have to multiply top and bottom by 2, right? And this would make it 4/6. So our equation is now 4/6 plus 1/6. Now we're working with equal portions, 6s in sixths. So we add the numerators, 4 plus 1, which is 5, and keep the denominator, which is a 6. And our answer is 5/6 inches.